The top one's just a pretty straightforward trinomial, so I believe it factors out as x minus 6x plus 3. You comfortable with that? Now, it's not x squared minus 9, but 9 minus x squared. What's the difference? Well, it means you get a 9 minus x, a 3 minus x and a 3 plus x. So far, so good. Now, did you see the x add 3 and the 3 add x? They're actually identical. So you can do a 1-for-1 cancel. And it's not one of those cancels where you leave behind a -1, it's just a 1-for-1 cancel. X minus 3 and 3 minus x could be cancelled, but if you do those, you have to leave behind a negative, right? But a 3 plus x and an x plus 3 is a bit like saying 5 plus 3 and 3 plus 5, right? They're both the same thing. So you can do a 1-for-1 cancel. And that would just leave us with that fella.
Okay. I think I was overthinking it.
What?
Somebody just said, what? Was that one of your kids?
Yeah.
Or your only kid? Whatever. Right, well, let's get started, everyone. Since I think almost everyone is here, or everyone that I know that should be here is here, can I remind you that on Monday, I will not be here. Monday is going to be a non-math day for us. And if you look at the schedule, and the homework is due like 3 weeks ahead instead of the typical 2. So it won't be a big deal, I hope. In fact, we're ahead of schedule, if anything. So what's going to be happening is we're going to be working on finishing off this adding, subtracting, multiplying, you know, all that rational function stuff. And that's what we're going to be dealing with today. And then next week, we'll continue with that. And if we get that finished, we'll start the next section, although it won't be in the midterm. And the midterm is still going to be up to and including rational expressions. So anything else we cover will belong in, you know, the next final or whatever. Okay, so we know how to multiply and divide, and we also know how to simplify. That's kind of where we are right now. So now we're going to look at how do you add and subtract them. And we're going to look at simple ones and then more complicated ones, and how to simplify more complicated ones. We're not going to make it today, but after that, we're going to look at equations that have fractions, rational expressions in them. So let's go way, way back. How do you add them? Well, I'll start off with something that you probably won't get to do. And we're doing it with numbers before we start introducing variables. If I said to you, what's 3/7 plus 1/7, since they share a common denominator, you can just add the top things together and you get 2/7, right? Nice and simple, don't overthink it. That's all I want to, you know, just to remind you of the rules of the game. Now, if you got 8/9 and you said subtract 2/9, since they share a common denominator, you can just subtract the numerators. And in this case, you get 6/9. Now, sometimes you get an answer that you can't do anything else to, right? 2/7 is good. But do you notice that 6/9 can be simplified? And if a fraction can be simplified, in this case, you can divide that by 3 and you can divide this by 3. You're expected to do it. We are only going to be focusing on rational fractions, right? Rational expressions where the denominators are the same, right? So we don't need to do that. Oh God, can you remember having to do 2/3 plus 5/7? I mean, that's a way, way back in the distant past. Well, we're not going to focus on anything like that. We're going to simply do fractions that have the same common denominator. And that does make life a little bit easier, although there are going to be some problems with that as well. So let's start off with simple ones and then just work our way up. Suppose I had 5 and I wanted to add that guy. Well, they share a common denominator, so won't the bottom be x? And the rule for adding fractions that share a common denominator is that you're allowed to add the top, the numerator, and there is your answer. No problems with that? Let's make it 5 over 2x plus 3 over 2x. Now they share a common denominator, which is 2x, and you add the numerators and you get 8 over 2x. Now that guy there is finished. I can't do anything else to that guy, right? It's done. But think about 8 over 2x. Is there anything you could do with that guy?
Divide by 2.
Okay, and if you divide this guy by 2 and this guy, you essentially get 4 over x. So do you see the rule about you sometimes will need to simplify your answer? Works even although they're x's, just like it works sometimes when you do numbers, right? Some fractions can be simplified like this one, some don't. Some rational expressions, things with x's in it, can be simplified, this one, and some can't. And so hopefully you can look at them and say, yeah, I can take that one a little bit further and, you know, simplify it down. How about 3 over x minus 1 plus x over x minus 1. Do these two fractions share a common denominator?
X minus 1.
Yeah. So don't we just need to add the two terms on the top now? Don't go looking for things that are not there. That is the final answer. Right? No, you're not allowed to cancel the x's. These are not factors. These are 3 add x and x take away 1. We are finished. How about this fella? They're going to share a common denominator, right? That's the only ones that we're going to be dealing with right now. So that goes there. Shouldn't you take the first guy and add it to the second guy? Boom, boom. Those two should be added. You might not need this line right now, but I'm putting them in until you feel comfortable, and then you can decide not to bother. Now, that's a good looking answer, but I guess the question isn't, is it a good looking answer? The question should be, can we simplify it? Can we, you know, like we did last week? Can you see anything you could do to the top that might get you there?
No.
Okay, look again. 4x add 4. Can you see a common factor?
Would you add the x to the 4x and then the 1 to the 4?
Okay,
I
here
don't know.
goes.
The
Ignore
common
me.
factor is 4.
Common factor is 4. Yes, you got it. That's what I'm getting at. Can't 4x plus 4 be factored? Right, it's a common factor of 4. Now, if I pull out the common factor of 4, you're left with x plus 1. Now, let's look at this fraction here. Aren't you allowed to cancel factors with factors, right? A 1-for-1 deal. Now, what happens here is that this fella gets cancelled with that fella. I guess technically you leave a 1 behind. So that's what? 4 over 1. Wait a minute. That answer is actually 4. So those two fractions added together is actually equal to the number 4. There isn't even an x left in the answer. That's kind of surprising, but it happens. Okay, I think I better do another one or two of these guys to see if we can keep that thought going. How about this one then? Yeah. Okay, they share a common denominator. There we go. You take the first guy and you add the second. If you collect like terms, you get 3x, add 6. Now, that is a good answer, but it's not the best possible answer. Do you notice that the top can be factored with a common factor? What's the common factor this time?
3 or 2.
Yeah. 3 is the common factor. And then that leaves behind 1x, add 2. And if I put a little bracket around that guy, can you see a common factor top killing off a common factor in the bottom? In this case, x plus 2. And that leaves a 3 and a 1, but that's just 3. Are we good? So if you add two fractions that share a common denominator, you just add the tops together and you try and factor it and see if you can simplify it. Half the time you can do it, the other half it won't, you know, they'll be finished and you can't do it. But this fella. So you can take the numerators, the top numbers, which is that. And what do you get? You get that and that. You get 3x squared. Take away 9 over x minus 1. Now, hopefully that bit's not too difficult, right? We're getting used to you add the top guys together. Now, what might not be so obvious is that I can simplify that guy. Pretend it just appeared. I said to you, okay, here's a fraction, simplify it. If you're going to simplify a fraction, don't you have to factor it? And then you can do a 1-for-1 cancel. 3x squared minus 9. Can you see anything like a common factor that I could pull out?
3.
Okay. Now, if I pull out 3, oh, shooting space. I'm going to have to change the question to get, well, actually, I won't. I'll leave it alone. That question is basically finished. I'm now going to do a very similar version, only this one's going to be much more, I hope, interesting. Right, I just changed that guy there a little. Can I skip this line where I write the two things added in the answer, or do you still want me to do it? Can I just add them in my head and write the answer down, or do you want me to write them and then add them? How do you want it to go? I can skip, okay. So 2 and 1 gives me 3x squared plus 3 and negative 6 give me negative 3, right? Same kind of look as the previous question. Is there anything you can pull out as a common factor on the top?
3 again?
Or 3 again? Now, in this question up here, once I did it, I was finished, right? I couldn't do any more. There wasn't anything going on. I want you to look at this one because there's more. X squared minus 1. I mean, we've been doing a lot of factoring, so have in your brain factors. Thinking factoring. Can x squared minus 1 factor? Can x squared minus 1 factor?
Isn't it just like 1?
Well, what kind of 1?
Plus
Negative
9.
1?
And a negative 1. Isn't it a difference of 2 squares? Right? A plus 1 and a negative 1. Now, I factored a little bit more. Do you notice that in this question, isn't there some cancelling that can happen? There wasn't any cancelling here, right? But is there cancelling I can do in this fraction? Is there something at one for one cancel I can do?
X minus 1.
And everything in the bottom's disappeared, so I'll put a 1. Technically speaking, although you might not need that line, that's what we've got. But isn't that really not a fraction again? So we may start off with some really ugly fractions, and we probably will end up with pretty ugly fractions when we're finished. But can you imagine that sometimes they might simplify by factoring and cancelling? So every time you get to the point where you've added them and you've got the top guy and the bottom guy, think, can I do any factoring? Because that might well happen. In fact, I'm pretty sure it will happen a fair number of times. This one is like question 2 homework. And now we're going into the big league. Have a look at this guy. Oh, and I remembered something and nobody told me. We are going to have to do some practice at the magic cross method. Remember? So I'm going to do it shortly. Actually, I'm going to do it in this question. So we will get practice at it. They share a common denominator, so I just need to add the tops together. I believe that gets me 2x add 7. So far, so good. All I really did is add the top pieces together and write down the common denominator underneath that. I am going to factor that. So let's see what we have. 2x squared, take away 11x, take away 63, that magic cross method, right? So on the top, negative 63. What goes on the bottom? Oh God, I'm saying negative 63. You know, nobody's arguing with me. What goes on the top?
The product of negative 63 and 2.
There we go. And what goes in the bottom?
Negative 11?
Negative 11. Now, aren't we on the hunt for two numbers? That you multiply them together. And you get negative 126. But when you add these two numbers, or combine them if you prefer to use that word, these two numbers, then you get negative 11. Now, when the numbers are small, like 6 and 8 and 10, you could probably just do, you know, keep guessing until you got one. But that's a lot of work, isn't it? And you might not get it. And would you agree 126 is not the nicest number in the world?
Found one.
You found it?
Yeah.
You show off.
Want me to
I
give
like show off, so that's good.
it?
Tell us.
It'll be 17 times 18. Not 17, 7 times 18. Sounds like I said 7 times 18. Sorry.
7 times 18, and one of them has to be positive, right? And one has to be negative. So who is it going to be?
Oh, it'll be the 18.
You want to go to 18, right? So let's check it out. I've got my calculator handy. And then I'm going to show you how you could, as the method I'm going to show you is quite long and cumbersome, but at least it's guaranteed to get the answer. Could you imagine that you might say, oh God, I'd never guess 7 and 18, right? I'd be here all day if I had to do that. But I'm going to show you how you can actually come up with those numbers. But let's check ours out first. So 7 times 18 is 126. So I know that works. I'm not worried about the negative sign. And would you agree that the two of them get you negative 11? So it's a perfect match. So show you what one way of taking that problem on, right? So I'm going to look at negative 126. And then I'm just going to keep my eye on that later. Okay, so first thing you do is 1 and 126. Would you agree there's no way in the world that those two numbers, no matter who you make a plus and who you make a negative, they are never going to get you 11, agreed? So move on. You then pick 2. Well, you say, well, what do I do? You go 126 and you divide it by 2 and you get 2 and 63. Would you agree that they are never going to get you 11? And then you would try, because they don't always work, you try 3. And 3 and 42. Do you see what I'm doing here? I'm just going through 1, 2, 3. Would you agree they're not going to get me 11, right? What am I going to get? What, 45 and 30 some? I'll try 4 now, 126. If I divide it by 4, see how there's an ugly decimal? Can't use it. 126 divided by 5, ugly decimal, can't use it. 126 divided by 6, I get 6 and 21. Could you get an 11 out of adding or subtracting those two guys? Yep. Okay, we're about to get to 7 then. 126 divided by 7, and you get 7 and 18. Now, when you get to that number, do you notice that you should be able to get negative 11 if you made this positive and that negative? Do you see we've now got the guy that we wanted? How did you get yours? Were you just a lucky guess, or did you have a plan?
I just like to start putting random numbers, and once I see a number that's close to it, then
You
it
tweak
kind of
it.
like, yeah, then it puzzles. I like
Yeah.
to do like puzzle kind of like that. So
Yeah, that works too. So can you see this systematic approach is going to be kind of long, but eventually won't you get the right answer? You say, well, I'm going to go on forever. Not really. See, if you try the next number, 8, 9, and 10, you'll end up at a point where the numbers you're using are so big, none of them work anymore. So you stop looking, right? Now, we're almost done with this magic method. Doesn't this guy come into the story? Or is it that guy? Who comes into the story? What's the next step?
You divide 7 by 2 and negative
Yeah.
18 by 2.
And sometimes, and I'll have to do it here, they simplify. And I don't even bother writing those numbers because they don't get used anymore. They've done their job. And from here, we should be able to get our factors. Okay, I've got a 7 and a 2. Right, that's the first one. Which one of those numbers is the x's, and which one of those numbers goes after it? So is it 2x at 7 or 7x at 2, I guess?
2 is
Rachel?
for the x's, I think.
Yeah, you're right. And the other number is what? -9/1. Okay, so what's that going to get me? 1x. Take away 9. That was a lot of work, wasn't it? And hopefully you could do it twice as quick as I have. But we have factored it successfully, right? And we had to use the magic cross. So I was going to do some magic cross at the start of today, but this question kind of shows you why you need it, right? Hey, can we do any cancelling here?
2x plus 7.
Here's a little cheat for you. It doesn't work all the time, but it can work a lot of the time. Do you know these kinds of questions? The vast majority of them end up simplifying. And because of that, if I notice the top guy is 2x plus 7, isn't there a very, very good chance that the bottom guy is 2x plus 7 times somebody? So if you have a fraction and the top is x plus 8 and a really ugly polynomial, if the top guy is x plus 8, there's a very good chance that the bottom guy is going to be x plus 8 times something, right? And it kind of gives you half the answer, and it makes it a little bit easier, you know, to figure out which one works. Are we comfortable with this being a 1 on the top and an x minus 9 on the bottom, rather than the other way around? You see, this is in the bottom and the 1's on the top.
Okay, just a takeaway from last class, last Monday, the unanswered question, I got x minus 3 over x minus 9.
Oh, that's interesting. I mean, that sounds okay. Was it the correct answer?
I followed the magic cross method thing, and that's what I got.
Oh, well, for this question or for one of your other questions? Oh, you mean the one that I didn't do last time?
Yes, that was
okay.
finished.
Yeah, I gotcha. Right. Well, we're getting practice, so we're cool. Let me look at another problem. This one is like question 7. So it's 4x add 3 over 4x take away 7 plus 3x take away 7 over 4x take away 7. Now, I've noticed when I went through these homework questions earlier that they jump around all over the place. What do I mean like that? You get one question that takes you 15 minutes to do, and the next question takes you 15 seconds to do. Now, we just finished doing a really horrible one, right? That took forever. What happens is that you then start second guessing yourself and making questions a lot harder than they are. Would you agree that these two fractions share a common denominator? And now I can go 4 add 3 gets me 7x, and 3 take away that gets me -4. Are you happy with 7x minus 4 and 4x minus 7? And the problem is that you want to do more to it than you should. That's finished. You can't factor it. You can't simplify it. And some of you might say, wait a minute, isn't that the thing you take away and it's reversed and you cancel, it leaves a -1? No, it's not. It's a 7x take away 4 and a 4x take away 7. If you wanted it to be that, you know, that back to front guy, wouldn't you have to move the x over here? You know, it would have to look like this. Now, wouldn't that guy be one of those you could cancel and leave a negative behind? This guy is just finished. 15 seconds, done. The next question, take you 10 minutes. One after that, 10 seconds, right? So just have a note in mind. Some questions are so easy, you're going to make your life hard by trying to do more than you need to. Okay, here's the next one. This is a version like question 8. So we have 2x over x squared plus 5x, take away 14. And we're going to add I know what we're going to add. I don't want to make it the same question. I guess that's my problem. What could I add here? Just hold on with me a second. Plus 7 minus 2. Yeah. I want you to have a shot at that first. See what you get. I'll give you another 15 seconds and then we'll move and we'll have a look at this. Okay, here goes. 2x add x gets me 3x, take away 6. That was probably the easiest bit. Can you factor? Yeah, you certainly can. So let's factor it and see if something happens. Maybe it will, maybe it won't. What can you do to 3x minus 6? Anything you can do as far as factoring?
Take the 3 parentheses x minus 2.
Agreed. Would you agree this trinomial, this quadratic, is a nice simple one, right? We don't need to do the magic cross, right? We can just look for two numbers that multiply together that give me negative 14, but when you add them, you get plus 5. Did anyone figure out what the combination that makes that work?
7,
Positive
negative
7,
2.
negative 2.
I hear it in 2 places. Well done. Now, sometimes nothing is common, right? That doesn't cancel because they don't share. But in this case, didn't we get lucky? I consider this lucky. Won't this guy cancel with that guy? So your answer is 3 on the top, x add 7, and you're finished. Now, if this factored and this factored, but nothing was common, right? Nobody in the top shared anything with the guy in the bottom, you would just leave it like that, right? You would just put a big circle and say, I'm done, right? So some questions, you're going to add them together and, you know, the answer is ugly and it's still ugly, right? You know, it's finished. And sometimes you're going to add them and things can happen. I think that's me covered the adding. Is there anything about adding to that you want me to go over, or do you feel pretty comfortable about what we've done? Okay, so what we're now going to do is look at subtracting two fractions, and they're not an awful lot of difference, you know. Oh, Sarah got a thumbs up, good. So let's start simple. If you share a common denominator, do you see that you're allowed to subtract the two? Right? First guy, take away second guy. How about well, you get 2x and 3 take away 1 on the top, and now we get 2 over 2x. Is this guy finished, or can we do something?
Cancel out the twos.
So you cancel out the 2's, there's a 1 left behind on top, and now the answer is that guy. Let's do 4x plus 1 over x minus 3. Take away 2x plus 1 over x minus 3. And this is where people will make a mistake. Do not write down what I'm about to write down, because it is wrong. It'll look right, but it's wrong. So don't write it down, just watch it. Oh, you take the first guy and you subtract the second guy. But that looks right. And you keep telling me it's wrong. The reason why it's wrong is that you don't focus so much on this the way you should. I'm actually subtracting all of that. Not just the 2x, but the whole package. And now if you put a little bracket around it to emphasize that, what you're really doing is the first guy, take away both of the pieces on the second guy. Now this is correct. Do you see how that is a mistake that you may make? Because it's not always so obvious, because you tend to see the negative and only give it to the first term, when you've got to realize that this negative, this subtraction, is subtracting 2 terms, in which case it kind of distributes through both of them. So what do I get now is 4, and that gets me 2x, and 1 and negative 1 cancel. And that's the final answer. Are you okay with just being careful when you subtract? Adding is not so much a problem. You know, most people don't screw up the adding, right? The adding is kind of what you see is what you get. But in subtraction, be careful the second term, right? The guy you're subtracting.
So like with the negative and parentheses, you want to imagine if there's a 1 there. So
Oh, that would
turn that-
help.
so
Like
that'll
there's a 1
turn-
there and you're distributing it.
Yeah, so then the whole other part
Yep.
there will be negative.
That's a good way to help to think about it. Like it's a negative 1 of this guy, right? So you're distributing. This is similar to question 1. So 5x take away 7 over x take away 6. Subtract 3x take away 2 over x minus 6. And if I put a little bracket there, even although the question doesn't have it, it kind of helps me at least. So it's 5x take away 7, subtract 3x minus 2. And does it help if I put a little pretend 1 in there? I mean, if it makes it more confusing, don't write it. But can you see basically I'm subtracting those things? So first guy, subtract 3x, and subtract this guy becomes plus 2. Subtract 3x, subtract negative 2 becomes plus 2. Okay, combine like terms. 5 take away 3 gets me 2x. Negative 7 add 2 gets me negative 5. Can you do anything to 2x minus 5? Can you factor it? No. So you're finished. Yeah, finished. If I could have taken out a common factor of 2 or 1 or not 1, 2 or 7 or something, I would have done it just in case we got lucky and there was some cancelling we could do, but not in this case. Try that one. I'll give you a minute. No pressure. Okay, let's go for it. First guy, take away second guy. 5x minus 1, subtract both of these terms. So that's going to be 5x minus 1, subtract the 3x and subtract that guy becomes a plus. When you combine the x's, you get 2x, and when you combine the numbers, you get 2. Are we good? Is there anything I can do, even if it's just minor, to make it look a little bit prettier? Anything you can do to the numerator that could make it look a little nicer?
Factor out the 2.
Yeah. In this case, it doesn't really help any, but it kind of looks prettier, right? So factoring looks prettier. If you can do it, you should do it. So, finished. So one more, well, maybe two, no more than two. Exceptionally ugly one. I need to find a really, really ugly one. Okay. 2x over x squared plus 5x, take away 14. Subtract 4 over x squared plus 5x, take away 14. So that's going to be x squared plus 5x, take away 14. And that's pretty straightforward, right? Do you think that's going to be the final answer? No, agreed. Should we factor everything in sight just to see what we get? I've actually done that bottom one, haven't we? Can anybody remember what the combination was to get this? It was either that or something very like it. Can't remember now. Two numbers multiplied together give you negative 14, but when you add them, you get plus 5.
7 and 2.
Yeah. Is that the same as the other one, or it just looks similar? Don't really matter if it isn't, but we comfortable with that. Is there anything you can do with 2x minus 4? Even trivial, do it.
Factor out of 2 and then x minus 2.
And now it's actually quite helpful to do it, isn't it? Because you can see a 1-for-1 cancel. Which means that the final answer is that guy. So this ugly fraction, take away this ugly fraction, actually when you subtract them, ends up being quite a nice looking answer, right? 2 over x plus 7. Do I need to do another one? I'm not sure I do now. You feel comfortable about subtracting? Right, so we've added and we've subtracted. Common denominators, I like that. So let's give you to finish off, weird answers. What could he mean by weird answers? Well, that's going to be a weird answer. I'll call that question 1. That's going to be a weird answer. I'm going to call that question 2. So you might think, what does he mean by weird? Let's find out. 4x minus 1, take away 4x minus 1. Well, they share a common denominator, and 4 take away 4. Oh, that's weird. How do you think you should write 0 over x minus 1 if it ever happens to you? So if it was 0 over 4 or 0 over 7, right? Wouldn't you just write 0? So if the numerator is 0, wouldn't that be a weird question? The answer to this take away this is 0. And then if you think about it, of course it is. And isn't this the same guy? You know, it's a bit like saying 42 take away 42, right? It just happens to be its fractions, right? This fraction take away itself should be 0. Not so silly after all. If you take this fella and you add them together and you just rearrange the order a little bit, you get that guy. What's weird about that answer?
They're same on the top and bottom.
Okay, and what does that end up being when you simplify it?
A 1.
It's kind of weird, isn't it? Getting 1, not an x in sight. Now, you probably won't come across, because there aren't that many questions in the homework where the answer ends up being a 1, or it might end up being a 0. But I think it's worth showing you that those are possible, because you never know what you're going to see in the future. You know, adding 2 fractions or subtracting 2 fractions can be all sorts of different answers, can't they? Sometimes you just get an ugly fraction. Sometimes it simplifies into a really nice fraction. And sometimes you get 0, and sometimes you get 1. And I'm happy if you're happy. Are we good on adding and subtraction? You feel great, right? There are only 9 homework questions, so it's not a big deal, right? You're not going to be doing an awful lot of examples. So try and get as much out of the questions as you can, since you're not going to get an awful lot of practice. I'm now moving on to number 9, homework 9. It's got a very generic title called complex fractions. Now, these guys, you haven't seen anything quite like them. They are weird, and the thing that they share, right, what makes them all kind of part of the same thing, is that you're going to get fractions where the top and the bottom, the numerator and the denominator, are also fractions. And your job is to take that really messy, complicated fraction, complex fraction, and make it pretty, simplify it. But we're not going to be doing the usual factor, cancel kind of technique. That doesn't work with these. We're going to show you a totally new technique for dealing with them. So this is a version of question 1. On the top, we've got that fraction. And on the bottom, you've got that fraction. I'm doing a much simpler version first.
You're not sharing your paper.
Well,
that
I
you're
could
writing on.
see it. Well, I don't. Thank you. Right. This is a much simpler version of question 1, but I am going to eventually turn it into question that is very, very similar to 1. Now, this is the problem that we've got. Do you see? I don't know if brackets help. Maybe they do, maybe they don't. Can you see that the top of the fraction is y over x, and the denominator, the bottom, is 4 over x? And you might think, well, how on earth am I going to make that nicer? In other words, how am I going to get rid of these fractions and still have an answer that's mathematically equivalent to that? And the technique that we're going to use is a magic version of 1. If you multiply a fraction by 1, you do not change its value, you just change what it looks like. So I am coming back to that guy. But let's talk a little bit about what a magic version of 1 looks like. Suppose I had the fraction 5/10, right? It happens to be a half, right? I could multiply it by 2 over 2. Isn't 2 over 2 just 1? Right? Any fraction where the top and the bottom is the same. Now, if I multiplied this by 2 over 2, wouldn't I get 10 over 20? Isn't 10 over 20 a half? Isn't 5 over 10 a half? Aren't they just 2 versions of the same answer? Right? They are what we call equivalent. They don't look the same, right? They have different numbers in them, but mathematically, isn't that guy worth the same amount as that guy? Now, you can take a fraction like 3/4, and you can multiply it by a special version of 1 called x, right? X over x. If you agree, x over x is 1. If the top and the bottom are the same guy, it's a 1. Now, in this case, you end up with 3x over 4x. Don't we normally go that way? But it looks like we're actually kind of changing direction, and we're taking this and making it that. So the idea behind it is that as long as you multiply a fraction by any version of 1 that you like, the answer that you get will be equivalent to the original. So this is the magic version of 1 I'm going to use. Now, if you take the top fraction and multiply it by x, and you take the bottom fraction and you multiply it by x, let's see what happens. What do you get if you take y over x and you times it by x? What does that actually become?
YX.
Ah, you're getting an x there.
X.
Do you really need the x, or is it just y?
Oh yeah, you can cancel out the X.
Yeah, and so don't you just get y? Let's show you the side. If I said multiply by x, if it helps, I'll call it x over 1. Don't you get yx over x, and then you can cancel the x's and just get y over 1, and you get y. If I said to you 3/4 times 4, won't the answer be 3? If I say 7/9 times 9, won't the answer eventually be 7? That's kind of what's happening here. So what is going to happen to 4 over x when you multiply it by x? What's that guy going to be?
Just 4.
And do you now see you've got your answer? Ugly fraction is the same thing as y over 4. complex fraction has now been turned into nice fraction. So far, so good. How about y over x again? And x over y. Now I'm going to multiply, put my little brackets in. I'm going to multiply by special version of 1. If I multiplied the top and the bottom by x, well, it would help out this guy, wouldn't it? But it wouldn't be much use to this guy. If I wanted to make this guy here, this bottom disappear, I wouldn't have to multiply it by y. Do you see that the magic version of 1 that I'm going to use isn't just x over x? It's not y over y, it's actually xy over xy. And that's the trick. If you can figure out the magic version of 1 to use, then you should be able to simplify all the questions. So I'm going to take this top guy, and if I put a little 1 over it, I don't know if that helps. What do you get if you multiply this guy by that? Well, won't the x's cancel out? And won't you get y times y, which is y squared over 1? Don't you get y squared? So the top is y squared. Now the bottom fraction looks like that. And if you multiply it by x, y, the y's cancel out. And you're left with x squared. There's your new answer.
Can we do another one of those?
Oh God, yes. We're going to do quite a few of those. Right. Let's do 4x over b and 3xy over b. What magic version of 1 do you think I'm going to use in this question? I don't just randomly pick things. There's a reason I choose what I did choose.
B?
B over B.
Agreed. Would you agree in this question, you know, that'll take care of both fractions. Now, I guess I should do it over here. That way I can hide it. Right there, I'm hiding the bottom so it doesn't disturb us. What happens when you take this fraction and you multiply it by b? What does it become?
4x.
4x.
Great. Now, hide that guy because it's a subtraction. What happens if you take this fraction and multiply it by b?
3x.
With a y, agreed? 3xy.
Yeah, sorry.
Now, look at our new guy. Isn't he much prettier than the guy we started with? And most of the time, you're finished, but not all of the times. Can I do any cancelling on this new fraction?
The x.
And if I cancel this x out with this x, doesn't our answer become even prettier? Now we're finished. Okay. I'll put that over here. How about y over x, that's on the top, and on the bottom, x over 5y. I need a magic version of 1, and I've deliberately made this one probably the hardest one. And then I'm going to show you how I make up my mind how to do the magic version of 1. And hopefully you'll say, oh, that's easy. Right. So we need to figure a magic version of 1 that's going to work in this question. Any ideas before we Go there.
Times y on both top and bottom.
Agreed. Do you need anything else?
X.
X.
Agreed. Do you need anything else?
5.
5. Now, if you're saying, how do we get, 5xy over 5? Why is that the magic one and not just x on its own or xy on its own? Why do I need the 5? The way I do it, this is how my brain works, is you see how that is on the bottom? And you see how these two guys are on the bottom? Do you notice that my answer is just put them together as one big guy? An x from the top and a 5y from the bottom. That's the magic version of one that you always choose, right? The one that uses a bit from each, right? Combines them together. Now, that might look, and it definitely does to me, quite messy, but it is going to come out quite nice. I guess we just have to be careful about what happens when you multiply this guy and this together and this guy and this guy together. Okay, if you've got a y over x and you multiply it by 5xy, what will you end up with?
5xy squared.
Will you? Will the x's be there?
No. Huh.
Right, so won't the x's disappear, but the 5y squared part is fine. I like that. Are you happy about the x's going away? Right, what about this fella? Who will get killed off here? And that way we can figure out what's left. X over 5y times 5xy. Who gets killed off when you have these fractions and non-fractions together?
5 and y.
Right, so you see that guy and that guy go away. And all you're left with in this case is x squared. Isn't that a much prettier answer? I think we should spend more time on these. I'm nowhere near doing the worst case scenario. You might think, oh God, surely they can't be worse than that. Trust me, there are ones worse than this, right? So I don't want to move too far. Are we getting a little bit more comfortable about the magic version of one to use? And then what's left in the top and bottom? If you do it correctly, shouldn't there be no fractions on the top and no more fractions on the bottom, right? That's definitely a sign that you're on the right track. Okay. Oh, by the way, that one there was question 1. So it took a while before we could even look at that one. Don't want to do that one yet. Yeah. God, you can't win for losing. There is only 7 questions here, and none of the ones that I've looked at that I want to do right away. So what I'm going to do is, we're eventually going to do one that looks like 2, but we're going to take it slow until we get to the place where it looks like 2. So the first couple of examples won't be that similar. So on the top, 7t squared over 8x squared. That's the top fraction. And on the bottom, 3t over, what shall I do? 3t over t. There we go. Now, based on what we've done before, isn't the magic version of 1 going to be 8x squared t? Are you happy about 8x squared and t? Right? 8x squared and then a t. Right? See if that was t cubed, wouldn't it be 8x squared t cubed? Right? Now, top and bottom. Okay, Peter. So what we're going to have is 7t squared over 8x squared, like that guy, times him. And on the bottom, we've got a 3t over t, also times him. Well, what we kind of have to figure out is what's left on the top, what's left on the bottom, and take it from there. If you multiply this fraction by 8x squared, don't the 8's cancel out and the x squared cancel out? So all you're really going to have left is 7t squared times another t, and that's going to get me 7t cubed. Are you comfortable with that? Right. If you go to the next one, not much happening. Won't that t just kill off that t? And if you multiply what's left, you've got an 8 and a 3, so I guess that's 24, and you've got a t and an x squared. Would you agree that's much nicer than the original? Is there anything that you can tidy up in this fraction? Anything that you could cancel? Something on the top with something on the bottom?
The T's.
Okay. Now, if you cancel that one, won't you only use up one of these guys and still have t squared left? Agreed? So a t cubed and a t, you only kill off one. So what's that leaving me with? A 7t squared over a 24x squared. You're finished. Are you comfortable with that question? Right.
This
Now
hurts
this-
my head.
Oh,
Just thinking about it hurts my head. Oh gosh.
this is top-notch stuff you're doing here. The only good news is there's only 7 of them, right? So it's not like you're going to do tons of them. But it really does, yeah. Before I do the real version of 2, there are 2 theories to learning stuff. And the first theory is that your brain can only hold a certain number of facts or information. And if you learn something new, you have to lose something. So it's like in one ear, out the other, right? That's the first version. Right? And really clever people, whatever that means, they can store like 20,000 things, and kind of stupid people can only keep 2 things in their head. So if they get a third thing, they have to forget where they live, right? That's being silly. And it's a totally stupid theory anyway. And the second one is the one I believe in, which is as you learn stuff, your brain gets bigger. So Jamie, when your brain was hurting, do you know why it was hurting? We were putting stuff in your brain and it was getting bigger and it was squeezing inside your head and it was hurting you.
Yeah. It's just a lot when I look at it, because I was like, there's so much like numbers and like letters and like
Everywhere.
squares. Yeah.
Everywhere. And I want one day to become famous. I think if I give my students a hard enough question, somebody's brain's going to explode.
I have a question though.
And I'll have it on video and I'll be famous.
So when it comes to like tests and stuff,
Yes.
do we get to use notes?
Yes.
Yay, okay.
So have very good notes and organize them in a way that makes it easier for you to find them. This is the version of 2 that I have right in front of me now. And if you're really worried about a test, can I tell you that questions like this, if you get a question, it'll be just one question out of a lot of questions. So it's not going to be, 20% in my grade is knowing how to do these. It's more like 2% in my grade is knowing how to do these, right? It's not a major, it's important, but it's not a major thing that's going to be disastrous for you. Okay. If you can tell me the magic combination for this one, you are well on the way to pretty much taking care of these guys. I have an 8x squared and I have an x squared t. So what do I need? What's my magic version of one going to be?
X squared T.
You nailed it. Do you want to tell people your thought process, if you can put it in any words, why that was the right answer? Because it is.
8 squares on the bottom of the top fraction, or 8x squared is the bottom, and then x squared t is the bottom of the other one. So
And
just
since they
lump them
both have
together.
x squareds, you don't need to do it twice. I'm putting words in your mouth here, but it's, you don't need to call it x to the 4, right? You've got an x squared, you've got one, you don't need another one. if I make that happen, we have this guy, and then over here, we have this guy. So all we need to do is figure out what we get and see if there's anything else after that. If you take this fraction and multiply by that, have you noticed that there's a theme? Don't things get cancelled out and there's a bit left over and that's what you multiply? Would you agree the 8's cancel and the x squareds cancel? Agreed? The 8's cancel and the x squared cancel. So this guy times this guy is 7t cubed. That sounds familiar. If you take this guy, he cancels him. If you take this guy, he cancels him. And what you're left is this fella times 8, which is just 24t. Looking good? Sometimes that's the answer. You don't do anymore, you're finished. But not this time. Can you do just a little bit more and it's finished?
Is that 24t at the bottom?
Yes.
Okay.
Yeah, I
It'll
don't
be
know.
a t squared.
Yeah, so you cancel that and get a t squared. So we're finished with a 7t squared over 24. Yeah, I'll give you one like this, and then we'll move on to the next. There's other versions of this still to be done, but I'll do one of these and give you a little shot and see if it makes sense to you. So this fraction is 3ab over xy, so that's what's on the top. And 4x over 3y on the bottom. Simplify that complex fraction. Okay, let's get started on this guy. Let's cover this guy up. It's distracting me. Okay. I need a special magic version of 1.
I did 3xy.
Good, because that's exactly what you should have done. Hopefully you picked up. Do you notice you've got an X, you've got a Y and a 3? Does it matter if you've got more than one? No, as long as you've got it covered, you don't need to join them together, right? So 3xy will do the job. Now, this guy's going to be 3xy, and this guy's going to be 3xy. Now, in this case, the X and the Y cancel out the X and the Y. And you should be left with 9ab. And in this question, the 3 and the y cancel out, and you're left with 4x squared. Can you do anything to that fraction that I've now written? And that's good, because you're finished. Okay, we need a joke or a break. I need it as well as you two, right? So we're going to have a 5-minute joke. Tell me funny stories, whatever. Anybody got a funny story or a joke to tell me? Okay, Alyssa, go for it. What you got?
I have a funny joke.
Perfect.
Okay. So the kangaroo got out at the zoo. And so the zookeeper made the fence higher. The kangaroo got out again. So the zookeeper made the fence even higher. This kept going on till the fence was 12 feet tall. Then the kangaroo said, I wish he'd stop wasting his money and just close the exhibit door.
Oh, that's painful. Oh, God, my head hurts, and that's not with fractions. Who told you that, Alyssa? And whoever it is, did you hit them?
I read that in a magazine when I was little.
I do
That's just
kinda
kinda stuck
like
with
it.
me.
It is. It's so silly. I like it. Did you hear about Superman and no, Superwoman and Invisible Man had a baby? No, it was nothing to look at. That's all I got right now. Somebody else got a joke or a story or whatever. We all need a break. It gives our brain a chance to assimilate stuff.
I have a funny story.
Oh, well, go for it again.
So me and my friend, we were at this camp, and it was like a church youth camp.
Gotcha.
And the cabins didn't have bathrooms in them. So if we had to go to the bathroom in the middle of the night, we had to wake up one of the counselors. So we had bunk beds, and she was sleeping under me. And my bed was like this, and then the counselor's bed was like right here. So she, of course, wakes me up at 3 o'clock in the morning because she has to go to the bathroom. And I am no help at all. So I look at her, and I turn over and go back to sleep. And she goes, and then she wakes me up again. She's like, Alyssa, it's 3, wake up the counselor, I have to go to the bathroom. And I would go, it's 3 o'clock in the morning. And she's like, okay, whatever. So I rolled over and go back to sleep. So she wakes me up again. And then she's like, wake her up. And I was like, fine. So I look at her and I kind of wave my hand in front of the counselor's face because I'm tired. And I turn around and go, she's asleep. And my friend's sitting there like, no, she's asleep. So finally, the counselor, I wake up the counselor, and then I just go back to sleep. The next morning, our counselor was talking to, I don't remember who she was talking to, but she was like, somehow came up that she was like, yeah, I think there was a bat in our room last night. And I was like, what do you mean? And she was like, yeah, I felt something in front of my face. And so while she was waiting for my friend to come out of the bathroom, she was thinking, okay, how am I going to catch the bat and get it out of the cabin? Turns out it was my hand that was in front of her face. So that's kind of an infamous story in my family and with my friends.
Okay. I can't beat that one. I can tell you a story about a friend of mine. His dad, he worked as, I'm not sure what the job would be called. Do you know when your power lines go, the ones that are on the poles with the electric power lines? He worked for the electric company, and he worked in the Highlands. So he spent a lot of time away from home because you couldn't really come back and forward like that. So you one of those kind of 2 weeks there and 2 weeks back home kind of thing. So he was always repairing farmhouses and their power lines. And so he told us a story about how he was up in the Highlands and he was in a farmer's yard, and he was fixing the power cable. It snapped or lightning hit it, and he'd done all the job and it was all working, and the guy had got the power and he was quite happy. And it was just a little van he had, you know, with all the tools in the back. You know, I don't know if you have them in America, but they open at the back like this, or like, you know. And he got in and he drove away. And while he was driving away, he turns on the radio for, you know, music and that. And if you've ever been in the Highlands, there is no lamppost or light. It's just pitch dark, except for the lights on your vehicle. And he was listening to the radio, and he heard that an inmate from the criminally insane psychiatric prison that was in the Highlands had escaped, and they were telling people to be on the lookout for him and not to go near the person if you found him because he was dangerous. And we do that. I think you do it in America. Don't you put prisons in the middle of nowhere? So if they escape, they're easier to catch, you know, because there's nothing in the Highlands for miles. And so he was thinking, oh, okay, I'll make sure I won't stop for any hitchhikers. And he was driving a little bit further. And then he heard a noise in the back. And he thought, oh God, I've got a hitchhiker. And then he thought, oh no, it's not just a hitchhiker. I've probably got that crazy guy. You know, the insane criminal. He's going to kill me. And he's getting kind of worried. And he's driving. And he doesn't want to look round. Because, you know, like in the Psycho movies, if you look round, isn't it? Ah, you know, you're a goner. So he's just getting scared, getting more and more scared. And the thing in the back starts getting nearer. And he's really beginning to freak out here. And he thinks, I'm dead. You know, this guy's just going to kill me and steal the van and get out of here. I'm dead. And so he thought to himself, he thinks, the only way I can live is I'm just going to drive fast. If he tries to kill me, there's going to be a crash. And he hopes the guy's got enough brains to know he can't kill me while I'm driving like 80 miles an hour down windy roads on the side of mountains, right? Nobody's going to be daft enough to kill me in that case. So he's doing this, and while he's doing it, it's going round corners. Things are falling off the shelves and banging, and he hears growling. Rrr! And he thought, oh God, he is crazy. And he felt breath on the back of his neck and think, right, that's it, I'm dead. So he comes to the bottom of a hill and he slams on the brakes, and he thinks, that's it, I'm just going to slam on the brakes, open the door and shoot out. It's pitch dark. If I get away, I'll live. You know, I'll live. Hit the brakes. You know, everything fell, bangs, shot through, you know, wires and cables, and everything shot by him as he broke. He opens the door and he was out like a bullet. And he just ran. And he ran as far as he could. And then he just ducked down, and the door was open, so there was a light there. And he's thinking, okay, the guy's just going to steal it now and drive away, and I'm safe. And so he says, I'm just going to wait here, you know, and make sure he's not coming after me. You know, I'm safe. And what happened was an Alsatian dog comes staggering out, and because the door was open, you could see the light, and comes staggering out. He'd accidentally stolen the farmer's dog. I know, and the end of the story was he had to take the dog all the way back to the farm and say to the farmer, I didn't mean it, but your dog. And it does show you what your mind can do, because everything that happened made perfect logic in the sense that it was a crazy guy about to kill me. Even although what it really was just a poor dog getting battered about and some crazy guy driving down a mountain because he didn't want to stop. Allegedly a true story. One more joke and then we'll get started. I think we've gave our brains a chance to kind of chill out. Anybody got one? I've got one, but it's not, I don't know. It's kind of, I like it, sort of. It's not one of my favorites, but I like it. Okay. Health warning, Scottish joke, somebody's going to die. Okay. Scotsman, Canadian, and American die. They were in a car, the three of them, they hit a tree, they're dead. And they get taken to the morgue, and they're lying on the morgue. Doctor's just checking them over. And suddenly the American guy wakes up and he's alive. And the doctor's amazed. They thought, you were dead. You were guaranteed you were dead. What happened? And the American says, well, me and the Canadian and the Scottish guy were, we were at Pearly Gates and St. Peter was there and they had the book and we were going to get in, and we went and said to him, look, we're too young to die. I don't want to be in heaven yet. Can you not just send us back, turn a blind eye, pretend you never saw us and let us back on earth? And St. Peter looks around and there's nobody paying attention. He says, look, if you give me $100, I'll do it. So the doctor says, oh, what did you do? And he says, well, I went into my wallet and I gave him $100. And here I am. And the doctor looks and the Scotsman's still lying there, and looks the other side and the Canadian's still lying there. And he says, well, what about the Scots guy and what about the Canadian? What happened to them? And the American says, well, the last time I saw the Scotsman, he was arguing about the price, and the Canadian said he was just going to wait for his government to pay for it. I got one crying face. All that hard work for that. One blinking crying face. You lot are a tough crowd.
That was a
thank
laugh.
you. Okay, that was a laugh. So it wasn't that bad, Francis. You actually liked it. Okay. Dawn, I think I saw a small smile on your face. Did you like that joke? You did. Okay. Did you get the gist that Canadians have a health service or someone else pays for it? That was meant to be that. And the Scotsmen are tight with their money, so he was trying to get a better deal. Okay, let's get back to work then. Okay. Whoops. Although there's only, I think, 7, 8 questions here, there's a lot of work in them. So this fella here is question 3, or at least like it. And I've now introduced, as if it wasn't bad enough, an extra issue. It's not fraction over fraction. We've been dealing with them. It's fraction plus 5 over another fraction, take away 4. And I'll put my little brackets around it. The good news is, it's special version of 1. Magic version of 1. And you might think, what do I do about this 5 and what do I do about this -4? Does that affect the 1? No. Ignore them. Doesn't matter right now. Would you agree then that as far as the fractions are concerned, isn't y over y going to be the only guy I need? Right? If you ignore them, isn't it just y in the bottom in both cases? Now you might say, well, I wonder how that's going to turn out. Well, let's see how it turns out. If you take this guy and you multiply him by y, and you take this guy and you also multiply him by y, let's see what you get. Think of distributing. Y times 1 over y, right? Y times 1 over y gets you 1, and 5 times y gets you 5y. Okay, let's look at the bottom. What will 5 over y times y get me? 5 over y times a y. What will they get me?
5.
And won't -4 times y just get me -4y? And don't overthink it, that's the answer. So we're using the same technique, even although this question had a +5 in it and a -4, it was still the same technique.
I have a question.
Yes.
Why wouldn't it be 1y and 5y in the beginning of the equations?
And so what was the special version of 1 you were thinking it might be? You said 5y and 1y. I'm just trying to think of where you wanted them to go.
And the answer, wouldn't it be 1y plus 5y and then 5y minus 4y?
Ah, okay, let's show you what's going on here. What we have here is this guy times y. So that gets you 1 over y times y plus 5 times y. I'm basically distributing each of these. And that doesn't get you y. They cancel out and you get a 1. And that gets you 5y. So that's why there's not a y there. Are we good with that one? Any questions about it? Okay. Let's move on to, there's only one of them. Let's see if you can handle this one. It's 5 on the top, and it's a 1 over x plus a 1 over y, and it's still going to be a special version of 1. Okay. Essentially, we're trying to get rid of these two fractions, right? We don't want them to be fractions anymore. So what special version of 1 do you think might make this
XY.
xy? Does that seem reasonable? That's the right answer. Does it seem reasonable? Now, if you multiply 5 by xy, you just get 5xy. Great. My dog is agreeing with me as well, by the way. Right. Now, what about this fella? I want you to think of xy times this fella, and then separate from that, xy times this guy. So let's do them one at a time. If you take 1 over x and you multiply it by xy, what's left?
1 over x squared.
Well, let's look it down.
I'm always overthinking it. I don't know.
All right. Okay. See, when you do this guy, if you put it with a 1 over it, do you see basically you're just killing an x off, and what you're left with is a y. So 1 over x, xy. The x and the x cancel, and you're left with a y. Okay. What would 1 over y times xy get you?
X.
Yes. And obviously plus x. And don't overthink it. That's finished. So if you can find, in these two questions at least, if you can find the right magic version of 1 and you multiply them out correctly, what you've got left was basically the finished product. There isn't anything else I can do with that. Right. We're getting darn close. Yeah, there's 3 more to go. And that will be the end of these guys. 5. This is like 5. So there's a 2 on the top. There's a b over a. Take away an a over b. And everybody is going to be a magic version of 1, every single question. Have you got an idea about what this one would be? What magic version of 1 would I use this time?
AB.
Okay. Is that bit of the puzzle getting a little bit easier? The magic version of 1 is. You might be having trouble with what you do with the next line, but you feel comfortable about AB over B and why it's that particular combination. Right. 2 times AB just gets you 2AB. Okay. AB times this fraction. AB, right? B over A times this guy. Whatever way you want to say it. What you gonna get?
B.
A.
Right, you seem to want to keep the A's. Let's see if we
No,
can.
I don't know.
B.
Let's try and saying it might be too much going on. So I'll write it. If you take this guy and you multiply him by this guy, that's what we're really doing here. If you make this guy over 1,
Oh, okay. I see it now.
see it? It might be a good idea just to have a piece of scratch paper and do that and then take the answer. Because if there's too much going in your head, you can maybe lose a place a little bit. So would you agree that you just get a B times B, you get a B squared? Okay, take away, put that in. Right, an A over B times an AB. What's going to happen this time?
I'm gonna give you a square.
Yeah. Okay. Are you good with that answer? Right. We'll just put a big circle around it and call it good. Two more to go. Question 6, question 7. That's the last two of these. And then we'll be finished. Oops, this bunch. Tons of time. So this is question 6. Oh, we're back to having fractions everywhere, top and bottom, numerator and denominator. What special version of 1's going to take care of this guy?
7y.
Agreed. Do you agree 7y? Right. So what we need to just kind of maybe be careful about is what you get when you multiply them out. And you know, that'll be the answer when we're finished. So I'm going to take each of these calculations and I'm not going to say them, I'm going to write them down instead. So if you take the top one, which is this guy, times 7y over 1, right, that might help it. Can you see that there's a 7 cancels? And what you're left with is 2y squared. So that's what the top gets me. Now you take the next one, which by sheer coincidence isn't it the same calculation. But just for completeness sake, I'm going to write it down anyway. You've got this guy times 7y, and the 7's cancel because it's the same question, and you get the same answer. So, yes, I didn't really need to do that. Take away, put that in, minus. And I've got a 6 over y, right, this guy, times that fella. And when you get this one, do you see that it's the y's that cancel out? And the numbers that are left behind give you 42. Now, I'm just rewriting this guy again because my subtraction sign got a little bit weird. That guy doesn't get a circle around it yet. And it's not a major tidying up, but we're still expected to do it. Can you see anything you can do on the bottom, even if it's very trivial? Anything you can do with that?
Divide by 2.
Okay, I'll take out a 2 and divide. And so the final answer, the one I'll put the bubble around, is that one. Are you happy about that question? Any questions? It's kind of the more you do, the better you get kind of situation. Right? Since at least I don't know of any questions, I'll go for the last one of these, and then I'll give you one to do, and we'll call it good, this particular section. I think we're getting pretty good at the magic version of 1 to use. What would the magic version of 1 be for this question?
XY.
Hopefully I'll see a lot of nods. You feel comfortable about the XY part, right? Okay. Now, just like I did the last time, I'm going to actually write these guys down and not just do them in my head. So 9 over x times xy. Right, that's going to be him times that guy. Right. Well, if you cancel out the x's, you get 9y. So that is the first fella. Right. Add. The second fraction is 8x over y, and you're also going to multiply it by xy. But in this situation, the y's cancel out. And what do you get? You get 8x times another x, so that's 8x squared. And then the last one is 4 over x, and you multiply it by xy. And in this case, the x's cancel. And 4 times y gets me 4y. And that is the end of the line. That one's finished. So until you feel comfortable about kind of saying it and doing it in your head to get these, you might just want to have a piece of scratch paper and do this and then transfer the answer over. Okay, you know I'm going to give you one, right? Let's do it then. Excuse me. 4 over A plus 5 over B, 6 over A, take away 7 over B. Simplify that guy. I don't know how long this will take. I'll give you 2 minutes. Last few seconds. Okay, let's go for it. And you can finish it off with me if you haven't quite got to the end yet. I need a special version of 1, don't we? What special version of 1 is going to work for this fellow?
AB.
AB.
I get at least 2 people and a couple of nods. Does that That step we're pretty comfortable with, right? Most of us, AB. Now, if I take each of these 4 guys, 1, 2, 3, 4, and I multiply them by AB, right? So everybody is going to get multiplied by AB. And then whatever the answer is, I'll then write it down here, 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 and here, right? So if you do this one, the A's cancel out and you get 4B. Okay, what do you get if you take 5 over B and multiply it by AB, which is this question here? 5 over B times an AB, if you prefer. I'll stick.
5A.
Yeah. Agreed? So getting a little bit easier. You see more, the easier hopefully it becomes. Okay, this one, which is 6 over A times AB. What's this going to get?
6B.
Somebody else for the last one. What's this one going to get me?
7A.
When you look at this fraction, I don't think you need to look at it very long to realize that you can't do anything and it's finished. You agree there's no common factors or anything. You are done.
Is it supposed to be plus 7A or minus 7A?
Oh, it's meant to be minus. Well caught. Because that's minus. This is minus. Yeah, well caught. So far, so good. I don't know, I'm looking at my time. I don't know if I want to start the next one or not.
No, we already learned a lot about brain.
You need to just have time to absorb it. Okay,
Yeah.
how about then I'm just going to hang about for the next 20 minutes and you can say, look, I'm doing this question. Can you help me? How about I do that? Okay. So remember to say hi and bye-bye, and I will hang about for any questions that you might have, either on what we're doing or some earlier homework questions that you want help with as well. If you don't have any, then remember, Monday I will not be here. So you're only going to get Wednesday next week. So you're only getting 1 day. But as I say, we're ahead of the schedule anyway, so I'm not worried.
I actually need help solving this one problem on my
Sure.
math.
Let's get it started. Anybody who just wants to hang about to hear how to solve someone's homework question, because it might end up being your homework question as well eventually, feel free to do so. Okay, what do you want to do?
This one's for homework 6, and then I have the
Uh-huh.
problem written down. So it's a 2n squared.
2n?
Yeah, it's squared minus 12n
Uh-huh.
plus 10.
Okay.
And then it's a fraction, or like the line. So then on the bottom, it's a 2n squared minus 7n minus 15.
So 2n squared minus, did you say
7n
7n and
minus 15.
1, 5, 15?
Yeah,
Okay.
1, 5.
1, 5. So when I look at these, they're trinomials, but aren't they the ones that don't have a single? So that means we're going to have to do the magic cross method. Okay, so I'm just moving over here. I'll start with the first one. Okay, 2 times 10 gets me 20. I'm putting a big circle around it just for emphasis, right? What goes below then?
12.
Right, and a negative as well. Make sure the sign, if it's there, gets used. So aren't I looking for 2 numbers that multiply together that give me 20? But when I combine the 2 numbers, I get negative 12.
It'll be 10 and 2.
So, and would you agree that both of them are going to be negative numbers?
Yes.
Right. So I'll put a negative 10 and a negative 2. The colors just for emphasis. Okay. Now, what do we do with these numbers is don't we divide them by the coefficient, in this
2,
case,
yeah.
2. So I'm going to call that over 2. I'm going to call that over 2. And then I'll draw a new different one. And this guy becomes -5/1, and this guy becomes -1/1, right?
Mm-hmm.
And now I should be able to get my factors. Won't this give me 1x minus 5? Hey, where's my 2 gone? Oh, the little darlings. It is not, the bottom one is. The top one is not what I thought it was.
Oh.
You can pull out a common factor. Right? Common factor of 2. And then I can factor this one because this is just n-1, n-5. If I'd used this, I would have only have got that piece of the answer. It wouldn't tell me the 2.
Mm.
Right? Now, the second one, which is the one that's on the bottom, that definitely is, the magic cross. How do I know that that one is? If you look at these coefficients, isn't there no common factors? When I looked at this one, if I'd been careful, I would have noticed a 2.
Oh.
Right. So multiply these together, -30. And that should give you -7, right?
Let's see.
So 2 numbers that give you -30. And when you add these 2 numbers together, you get -7. Who does that? I'm going through my head. I got it. I got one.
Oh. 10 and 7. 10 and 3.
10 and 3. Who are you going to make positive and who are you going to make negative?
10.
Okay. Right. Now, don't you then divide by this number? So let's see what we get. Got that guy. And we got that guy. So this one on the left gives me 1n, take away 5. And this one gives me 2n, add 3. So I've already factored the top. It's 2 lots of n-1, n take away 5. And we've factored the bottom. And it's a n-5 and a 2n plus 3.
And then you can battle it out with the n-5.
And whatever's left is
And
the
then-
final answer.
Okay. Okay.
So the magic cross only worked really for the second one. The top one, it was better to take out a common factor and just do it a different way.
So if it has like the common factor, there's no need for the magic cross?
Hopefully, yes.
Okay. Well, that's my only question I had for you. So
Okay,
thank you.
well, you're welcome.
Bye-bye.
Hi, Jamie, do you mind if I keep this on the video so that if people go back and watch it,
Yeah,
they
you
could maybe get
can.
help from it?
Yeah, that's fine.
Okay, thank you. Carla, you got a question? Carla, do you have a question for me? Carla, I don't think you can hear me. You'll have to hit the space bar. I can't hear you.
There we go. Sorry.
Okay. Do you have a question for me?
No, I don't.
Okay, so well, then I can close off for today, and I'll see you on Wednesday, right?
Monday?
No, Monday's going to be off.
Oh,
I'm taking my personal day on that day, so
Okay.
there won't be any class. The rest of your classes will be running, just not mine.
all right. See you then.
See you then. Okay, bye-bye.
Bye.